Good afternoon, everyone. I am your reporter this afternoon. I am Angel Me Prosperoso Gasco, and my topic is all about Chapter 14 Algebra, Geometry, and Probability in the 17th century. In the early 17th century, the pace of mathematical development began to accelerate. Vieux's ideas in the use of algebra in analysis were critical in the new developments. Starting in around 1610, William Oughtred, Thomas Harriot, Albert Gerard, and others began to turn Vieux's notations into recognizably modern notation, while at the same time further developing history of equation. In the 1630s, Vieux's analysis was applied to geometry and reformulated into the new subject of analytic geometry. The theory of equation. Algebraic methods for solving cubic and quartic equations were discovered in Italy in the 16th century and improved on somewhat by Vieux near the turn of the 17th century. William Oughtred, 1579 to 1660. Oughtred was a cleric who eventually spent most of his time in mathematics and mathematics teaching. His major, the Clavage Mathematique, or the Key of Mathematics, first appeared in 1631 and had several subsequent editions, both in Latin and English. The Clavis introduced English readers to Vieux's symbolic algebra, and in particular attempted to show and did French predecessor algebra could really be considered as the analytical art, in which by talking the thing so as known we found out that we seek to, in other words. Oughtred felt that mathematical problems, including geometric ones, should be translated into symbolic equations and then solved by the methods of algebra. Thomas Harriot, 1560 to 1621. Harriot was entered the service of Sir Walter Raleigh after finishing his undergraduate studies at Oxford and went to the expedition to Virginia in 1585 as an expert cartography. Beside learning how to smoke, there a habit that ultimately led into his death from cancer. He also wrote a report of the coloniad and its native inhabitants, a brief and a true report of the newfound land of Virginia. Albert Gerard and the Fundamental Theorem of Algebra. Albert Gerard, 1595 to 1632, was much clearer than Harriot on the relationship between roots and coefficients of a polynomial in his 1629 work Invention, Novel in Algebra, or A New Discovery in Algebra, and also give first explicit statement of the fundamental theorem of algebra. He was also probably born in the Saint-Mihiel in the French province of Lorraine, but spent much of his life in Netherlands, where he studied at Leiden and served as a military engineer in the army of Frederick Henry of Nassau. Gerard's basic result in the theory of equation was the following theorem, to which he gave no proof. Theorem: every algebraic equation admits as many solutions as the denomination of the highest quantity indicates, and the first fraction of the solution is equal to the coefficient of the second highest quantity. The second fraction of them is equal to the coefficient of the third quantity, the third and the fourth, and so on, so that the last fraction is equal to the constant term. All this according to the sign that can be noted in the alternating order. Analytic geometry. Analytic geometry was born in 1637 of two fathers, René Descartes 1596 to 1650, and Pierre de Fermat 1601 to 1665. Naturally, there had been a gestation period, but early in that year, Fermat sent to his correspondent in Paris a manuscript entitled Ad Locos Planos et Solidos Isagoge, or the introduction of plain and solid loci. While at about the same time Descartes was readying for the printer the gallery proofs of his discourse de la méthode Pierre Ben conjure sa raison et cher la vendas les sciences, or discourse in the method of rightly directing one's reason and searching for truth in the sciences, with its three accompanying essays, among which was La Geometry or the Geometry. Fermat and the Introduction to the Plain and Solid Loci. Fermat began his study of mathematics with the Natural University curriculum at Toulouse, which probably covered little more than an introduction of Euclid's element. He became familiar both with Viet's new ideas for symbolization in algebra and with his program of discovering and elucidating the secret analysis of the Greek mathematicians. He began his own project of using Pappus annotation and lemmas in the domain of analysis to restore the plain loci of Apollonius. Descartes and the Geometry. Descartes was born at La Haye now or La Haye Descartes, near Tours, into a family of the old French nobility. Because he was sickly throughout his youth, he was permitted during his school years to rise late. He thus developed the habit of spending his morning in meditation. His also led him to the conclusion that little he had learned in school was certain. In fact, he became so full of doubts that he decided and abandoned his study, as he reported in his discourse on method. Lucid the rest of the youth to travel to see courts and armies, to frequent people of differing disposition and condition, to store up various experiences, to prove myself in the encounter with which fortune confronted me, and everywhere to reflect upon the things that occurred, so that I could derive some more profit from them. Thus, he participated in several campaigns during 30 Years' War before settling in Holland in 1628 to begin his lifelong goal for creating a new philosophy, suited to discover truth about the world. He resolved to accept as true only ideas so clear and distinct that they would be called known. Descartes and the equation solving. Descartes' rule of sign. An equation can have as many true or positive roots as it contains change of sign from positive to negative or from negative to positive. As many false negative roots as a number of times 2 or positive sign or 2 negative signs are found in succession. 24. As illustration, the equation of x to the fourth minus 4x cubed minus 19x squared plus 106x minus 120 is equals to 0. Has 3 changes in sign and 1 pair of consecutive minus sign. Thus, it can have up to 3 positive roots and 1 negative 1. In fact, the roots are 2, 3, 4, and negative 5. Descartes and geometric curves. There are probably several reasons why Descartes defined geometric curves by continuous motion rather than directly as curves having an algebraic equation. First, he is interested in reforming the study of geometry defining acceptable curves by a completely algebraic criterion which have reduced his work to algebra. Second, because he wanted to be able to construct the solution points of geometric problems, he needed to be able to determine intersection of algebraic curves. It was evident him to defining curves by continuous motion would explicitly determine intersection. The work of Jan Duet. John Dewey was a talented mathematician who, because of his family background, could devote little time to mathematics. Born into a politically active Dutch family, he became a leader in his hometown of Dort, and after the death of Prince William II of Orange, was appointed in 1653 to the position of the Grand Pensionary of Holland. In the effect and Prime Minister, he guided Holland through difficult times over the next 19 years, successfully balancing the complicating demands of England and France when France invaded Holland in 1670. However, the people called William III to return to the power. Violent demonstration ensued against De Wet, and he was murdered by an informative mob. Elementary probability. The modern theory of probability is usually considered to begin with the correspondence of Pascal and Fermat in 1654, partially in the response of a gambling question of the mere race to Pascal. Gambling is the oldest leisure activities. It would seem that the earliest times people had been considered the basic idea of probability, at the least of an empirical basis, and the particular had some vague conception of how to calculate the odds of the occurrence of any event in the gambling game. The earliest beginning of the probability theory. In Europe, the late Middle Ages, some elementary probabilistic ideas connected with dice playing were spelled out. By the 16th century, the idea of equiprobable events was beginning to be understood, and thus it became possible for actual probability calculation to be made. The earliest systematic attempt to make this calculation is the Liber de Lodo Alai, or the Book of the Games of Chance, which written about 1526 by Cardano. Cardano also was aware of the multiplication rule of probabilities for independent events, but in his book he recorded his initial confusion as to what exactly should be multiplied. Thus he calculated the chance of at least one. Blaise Pascal, probability, and the Pascal triangle. Pascal described his solution to the division problem in several letters to Fermat in 1654, and Curie in the more detail a few years later at the end of his Traité du triangle arithmétique, or trace on the arithmetical triangle. He began with two basic principles to apply to the division. First, if the position is given a player is such that a certain sum belongs to him whether he wins or loses, he should receive the sum even the game is halted. Second, if the position of the two players is such that if one wins, a certain sum belongs to him, and if the loses, it belongs to the other. And if both players have equally good chances of winning, then they should divide the sum equally if they are unable to play. Pascal was born in Clermont-Ferrand, France, and he showed his mathematical precocity very early. His father in time introduced him as a young man to the circle around Mersenne. Thus the young Pascal was soon acquainted with the mathematical development in France, including the work of Fermat. He began his own mathematical and scientific researches before he was 20. Among his accomplishments were the invention of a calculating machine and the investigation of the action of fluids under the pressure of the air. After 1654, however, his scientific interests were overshadowed by an increasing interest in religious matter. Never in good health, he died at the age of 39 after a violent illness. Christian Huygens and the earliest probability text. Christian Huygens, 1629 to 1695. Huygens became interested in the question of probability during a visit to Paris in 1655 and wrote a brief book of the subject, The Rationalists in Ali Ludo, on the calculation and gains of chance, which appeared in print in 1657. Huygens' value is similar to Pascal's notion, his Weber, but in the case of gains of chance, Huygens could calculate it explicitly. In modern terms, the value of a chance is the expectation, the average amount of one win if one play the game many times.